presentation covers the Renesas Synergy Platform DK S124 out-of-box programming guide. The purpose of this out-of-box program illustrates a multi-threaded application design that reads the analog values present on the potentiometer, light sensor, and temperature sensor and displays those values on the included PMOD LCD screen. The 3 LEDs on the board will flash or chase according to the value read from each of the light sensor or the potentiometer. Switch 1 and Switch 2 are used to select which sensor is used and whether the LEDs flash or chase. The objective of this video is to pair it with the application note to install, build, and run the example application in under 30 minutes. The high-level steps involved are: configure the DK S124 board for the out-of-box application, observe the analog sensor values change on the LCD screen, change the mode of operation using the 2 push-button switches, vary the frequency of the LED flashing using either the potentiometer or the light sensor, import, build, and debug the project, and following next steps, take a look at the out-of-box application design. The example application targets the Renesas Synergy S124 devices. To build and run the application, you will need a Renesas Synergy DK S124 board and a PMOD LCD display, which is included in the DK S124 kit. To build and run the application, you will need a PC running Microsoft Windows 7 or 10 with the following Renesas software installed. You'll need the Synergy E² Studio 5.0 or later, and the Synergy software package SSP version 1.1. This video is based on the application note Renesas Synergy Project SSP Project Template DK S124 Out-of-Box Programming Guide as of September 23, 2016. This application note is available both on the Renesas Electronics website at the displayed URL and the Renesas Electronic Support on the gallery located at the displayed URL. Connecting to the board. First, verify the J3 header near the battery is configured with 2 jumpers to make connections 1 to 3 and 2 to 4. Second, connect the PMOD. And lastly, connect the J-Link to J14 on the DK S124 to the PC using a micro USB cable. Once the DK S124 is plugged in, it powers up and immediately starts flashing the 3 LEDs, LED 1, LED 2, and LED 3, and displays a simple splash screen on the PMOD LCD for 2 seconds. This splash screen will show the board number and the version of the out-of-box software that shipped with the board. After 2 seconds, the screen will change to the analog measurement screen. The program displays the raw hex values read from the light sensor to the potentiometer, and it converts the analog value from the temperature sensor to the equivalent Fahrenheit temperature. You may interact with the out-of-box program in the following ways. The 3 LEDs, LED 1, 2, and 3, will all flash at once or chase one another. Momentarily pressing the push-button switch S2 will cause the LEDs to alternate between flashing and chasing. The bottom corner of the screen will indicate which mode the LEDs are operating in, flash or chase. The flashing rate of the LEDs are determined by the value read by the light sensor or the potentiometer. You toggle between these two by momentarily pushing the push-button switch S1. The bottom right corner of the screen will indicate which sensor is driving the LED's flashing rate, potentiometer, or light. With the potentiometer mode selected, press S1 and rotate the potentiometer clockwise and counterclockwise. The flashing of the LEDs will increase or decrease appropriately. The screen will display the raw value reported by the analog to digital converter. With the light mode selected, by pushing S1, move a light source, for an example a flashlight, closer and further away from the light sensor. Observe that the flashing rate of the LEDs change. The raw hex value displayed on the screen also changes. The next steps are to learn more about how the application works and the API calls involved by examining the application source code. To do this, follow the procedure in the Synergy Project Import Guide to import the project into the E² Studio ISDE and to build and debug the project. For the debugging configuration, select the executable and link format ELF of the DK S124 out-of-box debug under Renesas GNU debugger known as GDB hardware debugging. So let's take a look. We call up E² Studio. We identify the location of our workspace. We're in the configuration perspective, so we go to File, Import. We identify existing projects into the workspace, say Next, and then we look for our project. After selecting our project, you can see that it's checked. Next, we want to expand our files and select the configuration XML file. Once it is selected, we can go to the BSP, verify our SSP version, our board, and the device on the board. We now want to generate the content files. After we have done that, we can go over to the hammer, which is to build the file. Notice that there are 0 errors and 0 warnings. At this point, we can go into Debug Configurations. We want to select our DK S124 out-of-box debug and verify that the executable and linkable file is identified. We can now say Debug. Remember, there are 2 breakpoints. One is directly after the reset handler, or we'll just say resume. And the second is after main. We'll also say resume. Now at this point, you can see running. But more importantly, we already knew that it was running. So let's take a look at our configuration perspective. And here, we can go back to the DK S124 out-of-box Synergy configuration, and you can look at threads, the LCD thread, your input thread, and compare this to the application note. Now that you have imported your project into E² Studio and gone to the debugger, now you can go back to the configuration mode and investigate various inputs such as the next steps that allow you to get to know the conceptual design of the out-of-box design application. The 3 user-defined threads. The blinky thread controls the flashing and chasing of the 3 onboard LEDs. The LCD thread updates the LCD as new data arrives from the 3 analog sensors, and the input thread, which periodically polls the switch inputs and reads the analog sensor voltages. After you run the example application, beginning with the out-of-box application design, located in Chapter 4 on page 5 of the application note, you can learn more about how the application works and the API calls involved by examining the application source code. This includes the input thread logic, the accelerometer initialization, LCD thread logic, blinky thread logic, threads and modules, PMOD LCD library, and source code layout. You'll recall from the objectives at the beginning of this presentation, we are to pair the application note to install, build, and run the example application. The high-level steps involved are configure the DK S124 board for the out-of-box application, observe the analog sensor values change on the LCD screen, change the mode of operation using the 2 push-button switches, vary the frequency of the LED flashing using either the potentiometer or the light sensor, import, build, and debug the project, and following next steps, take a look at the out-of-box application design. This concludes this presentation. Thank you for watching.